Hi class, as promised, this is your review for your test on polynomials coming up next class. I'll try to make it as quick and painless as possible. So one thing we've covered in this unit is adding and subtracting polynomials. And so I'm going to go over just a couple examples of how we do that. One important point to remember, and that I've tried to emphasize throughout, is that we can only add and subtract like terms. Like terms are terms that have the same variable and exponent. So the steps that we've been following to do adding of polynomials and subtracting polynomials is to get rid of the brackets. First, to rewrite the question without the brackets. So I'm going to do that here. So I would get 2x squared plus 1 plus x squared minus 2x plus 1. And you can notice that all the operators in the brackets, this negative here, this plus here, they stayed all the same because there was an addition sign outside of the brackets. So I'm just, as a habit, getting used to the idea of taking off the brackets first. This clears it up so that I can then do what we've been working on doing next, which is to box the terms as well as the operators in front of them. So I'm going to do that now. So I would box 2x squared plus 1 plus x squared minus 2x and plus 1. Now I want to reorganize my terms with the terms with the highest exponent first, so that I would then get 2x squared plus x squared minus 2x plus 1 plus 1. And now I want to combine my like terms, so I would get 2x squared plus x squared equals 3x squared. Nothing to put negative 2x with, so it just remains negative 2x plus 1 equals plus 2. And that's the answer to that question. So again, as I noted, the steps we're following is we took off the brackets, we boxed, we reorganized with the terms with the highest exponents first, and then we combined our like terms. So let's do another question here. Again, we'll follow the same steps of taking off the brackets. The thing to take note of here is if there is this negative sign in front of the brackets, then we have to change the operators inside the brackets to their opposites. So I'm going to rewrite the equation without the brackets. So I would get 2a squared plus 3a squared plus 2a minus 2 minus a squared. So that a squared was positive, now it's minus a squared or negative a squared. And this is going to become plus 3a because I've changed the negative to a positive, and minus 7. After I've done that, now I'm going to follow the steps that I follow for the other one, which is I'm going to box all the terms and the operators in front of them. Okay, it's very important that I get the operators in there as well, as the number, when I reorganize it on the line below, needs to have the same operator in front of it. So now I'm going to reorganize my terms so that I start with the terms that have the highest exponents, and I would get 3a squared minus a squared plus 2a plus 3a minus 2 minus 7. Now I'm going to combine my like terms. 3a squared minus a squared is going to give me 2a squared. 2a squared plus, 2a plus 3a is going to give me 5a. And negative 2 minus 7 is going to give me negative 9. And there I have my answers. And I'm just going to add in, we should be putting our equal signs here. Alright, so that's how we do this, and the important point to remember is that when you have the negative symbol outside of the brackets, you have to change all the operators inside the brackets to their opposite when you're taking the brackets off. So the next thing we're going to look at is multiplying polynomials. So in this case, I have a monomial in the 7 here, and I have a trinomial in 4x squared plus 3x plus 6 inside the brackets. And when I'm doing this, the thing to remember is that I need to multiply the term outside of the brackets by each term inside the brackets. That's called the distributive law. So I'm going to be multiplying 7 times 4x squared. I'm going to be multiplying 7 times 3x. I'm going to be multiplying 7 times 6. So let's get started with that. 7 times 4x squared is going to give me 28x squared. 7 times 3x is going to give me 21x. And 7 times 6 is going to give me 42. And that's just as simply as you do that. Now, one thing that you can do to help you remember or think about what you're doing here is if you have just a constant, you're just going to multiply that constant 7 by the coefficient, and you're going to leave the exponent and variable exactly the same. Okay, so all I did there is I did 7 times 4, that gave me 28, and I left the variable x and the exponent 2 exactly the same in my answer. And I did the same thing for this one here, 7 times 3x. I did 7, the constant, times the coefficient 3, and I left the variable exactly the same. And then obviously 7 times 6 is 42. Alright, so let's work on the next one here. We have 5n bracket 6n plus 4. Again, I'm going to be using the distributive property here, and I'm going to be multiplying 5n times 6n, and I'm going to be multiplying 5n times 4. So in this case, I have a coefficient and a variable that I'm multiplying. So it's important that I multiply the coefficient by the coefficient of the other term, as well as multiply the variable, in this case n, by the variable in the other term n. And an important thing for us to remember here is that if I'm doing two variables like n times n, I'm going to end up with n squared. So let's work out this question here. 5n times 6n, I'm multiplying the coefficients. I end up with 30. Now I'm multiplying the variables. I end up with n squared. 5 times 6 equals 30. N times n equals n squared. Now if I'm doing a coefficient and a variable, as I am here, 5n times the constant, it's the same thing like I did back in this question over here, where I did 7 times 3x. I'm going to multiply the constant by the coefficient, and I'm going to keep the variable the same. So if I do that here, 5n times 4, and that will give me plus 20n. And those questions are done. So let's do this example next. A little bit more complicated, but not that much more. Based on all the two ideas we've just covered, you should be able to do this one as well. Alright, so here I'm going to be doing 5n times 6n and 5n times 4. And then over on this side, when I write this out, I'm going to be doing negative 3 times n squared, negative 3 times negative 2n, and negative 3 times 2. And again, I'm using the distributive law here to get this done. So let's go through that. So 5n times 6n is going to give me 30n squared, as it did for me above. 5n plus 4 is going to give me 20n. And then now I need to do my negative 3 times n squared, and that's going to give me negative 3n squared. Negative 3 times negative 2n, that's going to give me positive 6n. And then negative 3 times positive 2 is going to give me negative 6. Okay, so now that I've taken the brackets off of these and by applying the distributive property, we also call this expanding. So I'm just going to write that there. I got to expand this, and that's what I did up here as well. I should have mentioned that earlier, but better late than never, right? So that's what we did here. We expanded. Right, we just expanded using the distributive law. We took the brackets off and wrote the terms out. So now what I need to do is I need to collect my like terms, and we can use the strategy that we've been using for that, which is boxing the terms first. Now that I've boxed the terms, I can select the ones and organize them based on the ones that have the highest exponents. So I get 30n squared minus 3n squared plus 20n plus 6n minus 6. Alright, so now that I've done that, I can combine my like terms. 30n squared minus 3n squared equals 27n squared. 20n plus 6n equals 26n. And there's nothing to combine minus 6 or negative 6 with, so I just end up with minus 6, and this is my answer here. So what I did here is I expanded first, and then I simplified. And I got my final answer. So other questions you'll see in the test will ask you to actually solve the equation. In those previous examples we just worked on, you were just simplifying expressions. You could not find a value for x because they were just expressions and not equations. In this case, we are solving, that is, we're going to try to find a value for x. And we've been working on this since the previous unit, so it shouldn't be too unfamiliar to you, but just in case, I'm going to go over it here. So in this case, we have 4x plus 8 equals negative 12. In order to solve this very simple two-step equation, I'm going to need to isolate x. To isolate x, I'm going to need to get rid of this plus 8 here to start with. And in order to do that, I need to subtract 8 from both sides. So I would end up with 4x plus 8 minus 8 equals negative 12 minus 8. And 8 minus 8 cancels each other out. They become 0, and I end up with 4x equals negative 12 minus 8 equals negative 20. Now I have, to isolate x, I need to get rid of that 4. The 4 is multiplying by x, and so to get rid of it, I'm going to do the opposite operation to it, which is divide by 4. So I'm going to divide by 4. If I divide that side by 4, I'm going to divide the other side by 4. And 4 divided by 4 equals 1, so I'm just left with x. And negative 20 divided by 4 gives me negative 5. And that's how you do that one. Alright, this next example here on the right is a little more complicated. And in this case, you have variables on both sides of the equation. Now, the idea still is to isolate x, and so to do that, you're going to have to move all of the variables to one side of the equation and all of the numbers to the other side of the equation. And once you do that, you'll be able to get the answer. So you could do this in more than one way for sure. But what I'm going to start off by doing is I'm going to move the 3x to the right-hand side of the equation. I'm going to try to put all of my variables over on the right-hand side of the equation. I'm going to try and put my numbers all on this side. So how can I move 3x to the other side of the equation? Well, I can do that by subtracting 3x from both sides of the equation. So how will that look if I do 3x minus 3x plus 50 equals 10x minus 3x plus 1. 3x minus 3x equals 0, so on the left-hand side, I'm left with the number 50. 10x minus 3x is going to give me 7x, and I still have my plus 1 there, so I have 7x plus 1. This equation now looks like something you're more familiar with and should be easier to solve. So I need to isolate x as always, and to do so I'm going to have to subtract 1 from both sides, so I can get rid of this one that's here on the right hand side. So if I subtract 1 from both sides, I get 50 minus 1 equals 7x plus 1 minus 1. And then I end up with 49. 50 minus 1 equals 49 equals 7x. And then in order to isolate x, I'm going to need to divide both sides by 7, because 7 here is being multiplied by x. And to get rid of it, I need to do the opposite to it, which is divide. So I divide both sides by 7, and I end up with 7 equals x. And so that's how you solve that kind of problem. The key there is just to remember that you want to put all of the variables on one side of the equation. So in this case, I put my variables on the right-hand side. And once I put the variables on the right-hand side, I was able to make the equation a lot simpler and solve it just using what we've learned for two-step equations. Again, another kind of question you'll get on the test will be like the one you see here. Write an expression for the area of this figure. So in order to do this question, I'm going to have to remember some of the things that I learned in the previous units, in Unit 1 in particular, about how to get the area of a composite figure. So the first thing that we've learned to do is to split the area up. You could split it that way like I just did, or you could split it this way. Obviously that line should be straight. For now I'm going to do it this way. And you're going to label them area 1, area 2, and then you know that your total area equals A1 plus A2. And using this I can then write an expression. Now one other thing I need to get done is I need to identify the unknown side. So this side here, for example, I do not know the length of, but actually not a problem for me in this one because I know the length of the total side, and that's going to be one side of a rectangle. But what about this one here? I don't know the length of this here. And that's fairly simple to find out. All I'm going to do is 2x minus x. So 2x minus x, and the answer is x. So the length of this line here is simply x. Alright, so let's do area 1 first. So I would do area 1 equals x times x plus 2. And that's because area is length times width. Not letting me write that in there for some reason. So area is length times width. So my one length is x, and then width is x plus 2. So now I can use the distributive property. X times x gives me x squared. I did x times x, and then x times 2, and that gives me 2x. Now I can do area 2. And I'll do, for space's sake, I'll do it up here, area 2. And that gives me length times width again. So the length here is going to be, we'll say x, because we found out earlier over here that the length of this side is x. And then the width we'll say is x minus 1. And we get that from over here. So again, I'm going to do x, the distributive property, so x times x and x times negative 1. And doing that, I'm going to get x squared minus x. Alright, now I need to do a total area expression, or expression that will describe the total area that I have here. And so if you remember, it's A1 plus A2. So I just need to take now these two expressions, this one here, A1, and this expression here, A2, and I can put them together, and then I'll simplify them, and I'll get the expression. So the expression is going to be x squared minus x plus x squared plus 2x. Okay, and I'm going to follow what I've learned to do before. I'm just going to write it without the brackets. Now I'm going to group them. Now I'm going to organize them with the terms of the highest exponent first. Alright, so that was x squared plus x squared minus x plus 2x. And x squared, now I'm going to combine the like terms. X squared plus x squared equals 2x squared. And negative x plus 2x equals positive x. And so the expression for this area is 2x squared plus x. Alright, this is the last question we're going to do in this video. And you're going to see this kind of question on the test. The question reads, this field in the shape of a trapezoid has a perimeter of 265 meters. A fence is being built along the field's perimeter. Determine the length of fencing needed for each side of the field. So let's apply cubes to this question so that we can make sure we answer it correctly. We're going to circle our number here, 265. We're going to attach it to the word perimeter so that we know that that's referring to the perimeter of this trapezoid. And then if we underline the question, determine the length of fencing needed for each side of the field. So that will help us to focus in on what exactly we're supposed to be doing here in this question. And let's box the word each side. We need to find out how much each side is. So to be able to determine the length of each side of the field, I'm going to have to figure out what the value of x is. So to start, what I can do is I can write an expression for the perimeter of this shape, and then once I've simplified that expression, I can then create an equation with the given perimeter of 265 meters. So let's start by writing out the expression. The expression is 6x plus 7 plus 5x plus 10 bracket x plus 2 plus 5x minus 5. Now that I have that expression, I need to simplify it, and once I simplify, as I said, I'll put it into an equation. So let's simplify it first. To simplify it, I'm going to have to expand two portions of it. I'm going to have to expand this portion here and this portion here. And so to expand, I'm going to do 6 times x and 6 times 7. And there I get 6x plus 42. And then I can write this out again, 5x plus 10. Oh, I got to do my expansion again, so I'm doing 10 times x, 10 times 2. So I get 10x plus 20 plus 5x minus 5. Alright, so now this is just like you've been doing all this time when you've been simplifying. You're going to box your terms. Once you've boxed your terms, you're then going to organize them so that the terms with the highest variables go first. So in this case, it's 6x plus 5x plus 10x plus 5x. And it's good here to use our check marks to make sure we get everything, because there's a lot of terms here. So did I get everything? Yes, I did. Now I can do plus 42 plus 20 minus 5. And so once I do that, 6x plus 5x plus 10x plus 5x gives me 26x. I can combine those like terms. And then 42 plus 20 gives me 62 minus 5 gives me 57. Alright, so that's a simplified expression for the perimeter of the trapezoid. So with the simplified expression for the trapezoid, I can now take the 265 that I got in the question, and I can substitute it in for the perimeter. Okay, so the perimeter here. So I'm doing 265 equals 26x plus 57. Now to isolate x, I'm going to have to subtract 57 from both sides. So 265 minus 57 equals 26x plus 57. (26x plus 57 minus 57). And on my left hand side then, I will end up with 208, because 265 minus 57 equals 208, and equals 26x, as 57 minus 57 equals 26x. Now, what I need to do in order to isolate x is divide both sides by 26. And I end up with the answer of 8 equals x. Now that I found the value of x, I can find the length of each side. So I'm going to do that up around the diagram. So I would get 5 times 8 equals 40. And this one, 5 times 8 minus 5 equals 35. And this one here, it's 6 bracket 8 plus 7, and that is the equivalent. 8 plus 7 is 15 times 6 equals 90. And then in this example here of 10x, I'm going to get 10 bracket 8 plus 2, and that's going to give me 100, because 8 plus 2 is 10. 10 times 10 is 100. And so those would be my answers. 35 is the length of that side, 90 is the length, and I should definitely remember to put my units of measurement for all of my answers, and put a square around them so that your nice teacher can find them easily. Alright, that's it for this video. I apologize for its length, but you can kind of fast forward through things that you feel like you already know, or skip through some of the commentary and get what you need from it. Good luck on the test.